Okay? So, I say we do some magic and we get this. We'll worry about the magic shortly, okay? But not right away. And it's just the integral where y goes from 3 to 6, because of course y goes from 3 to 6, of the integral when x goes from 2 to 4. Actually, it's the integral when x goes from 2 to 4 of the integral when y goes from 3 to 6 of this function. Okay? And that's a very easy integral. I'm going to actually do the integral, and you'll see how easy it is in this case. Okay? We take that integral and divide it by the total area of the region, and this generalizes that the average value of f of x parentheses, okay? The average value of f of x is just what you get when you sum up all the values of f of x and divide by the length of the interval. And if that's not totally obvious to you, review it until it is, okay? It's one of the most essential things that you bring out of a first-year calculus course, but for some reason people tend to lose the forest for the trees and not see this very fundamental, extraordinarily important idea, okay? So, well, let's go ahead and do the integral, okay? Very easy to do the integral, so let me write out the integral where it's a little easier to read. Okay? Well, first we do the y integral because it's inside, working from the inside out. And when we do the y integral, we treat x as a constant. So it's very simple. We get then 6y minus xy plus y squared over x evaluated between y equals 3. My y's keep looking like x's sometimes because that's what I actually write, sometimes just because I'm careless. Okay, but we evaluate this between y equals 3 and y equals 6. X is constant, okay? And what this gives us is the integral along any, okay, here's our x value, we just integrate this. Integrate along this path, x is constant, y is changing. And you can think how that articulates with a three-dimensional figure, but we'll talk more about that. The mechanics is just this simple. You treat x as a constant, you integrate with respect to y. So that's the integral from 2 to 4 of, well, 6 times y equals 6, y equals 3, and that's going to be 6 times 3, right? When we subtract, well, I'm just going to, okay. I'm not going to write out all the details, but when we evaluate this here and here and subtract it, we get 18, okay? Minus 3x plus y squared over x. Well, y squared is 36 here. It's 9 here. 36 minus 9 is 27. Okay? So if you evaluate this expression here, evaluate it here, this is what it's going to come out, and check my arithmetic, it could be wrong. Anyhow, we integrate that with respect to x. Well, what does that give us? Let's write it out carefully. That gives us 18x minus 3, oh, I got y squared here, it's y squared over 2, right? I mean, antiderivative of y is y squared over 2, and some bonehead forgot to write that down. Okay? So that'll be over 2x, okay? In other words, you got 27 halves times 1 over x. But okay, so then we have 3x x squared over 2 plus, well, actually it's going to be minus 27 over 2x squared from x equals 2 to x equals 4. Right? And then we simply evaluate that. I'm going to go one term at a time. That's 72, and that's...
I think you messed up a part there with the 27 over 2x squared.
7 over 2x squared.
27 over 2x squared. I don't think that's how you integrate one.
Yeah,
over
you're
x.
right. That's, I took the derivative. It's a natural log. 27 halves natural log of the absolute value of x. Sorry. Okay? Like I say, watch me. And it would have come out wrong and I'd have had to debug it and find it, so I'm glad you found it. Okay, so this is going to be 72 minus 36, right?
Oh, and it isn't negative 27.
It's plus now. This is going to give us 36, right? Now, x squared is 16, 3 halves of that's 24. X squared is 4, 3 halves of that is 6. So that's minus 18. And then it's going to be 27 halves times the natural log of 2.
Algebra 2 honors and math.
Okay, natural log of 2 is about 0.7. And 0.7 times 27 would be 116.9. That's about 8.5. So this is really screwed up. It's nowhere near, oh, never mind. No, mine. Okay, so I'm getting like 18. No, I'm getting like 25.
I got 27.4.
Okay, 27. Approximation there, I probably did something else wrong too. Yeah, actually I'm adding something greater than 8, so I should have subtracted. Okay, anyhow. So we get about 27, right? Which is totally messed up, because when we divide by the total area, we get less than 1. And none of our densities were less than 4, right? So let's see what we did wrong. Because something's wrong. If we divide this by the total area, it doesn't work. So I did something wrong.
It looks right to me.